Our project is going to be on fracture and failure in wind turbines, and it's going to be by Ashley, Danny, Gerda, Camille, Kevin, and Oscar. For just a brief introduction, our project will provide a general understanding of how wind turbines are made and how they work. And then we will go into an in-depth discussion on the causes of fracture and failure in different parts of the wind turbine, including examples of these fractures and failures, and then finally provide potential improvements and preventative measures to decrease these failure rates.
So starting out with how they're made, here are two sites that I have found in terms of both the rotor blades and the overall wind turbine design. We will see later on exactly where most issues occur, but the tower is made usually nowadays from steel because of its lower cost and its strength and high stiffness, while the blades themselves are usually glass fiber fabrics and resin.
This is just an overview about wind turbines. I found two links, and they're offshore wind farmers. They spend around 15 billion USD on maintenance, and most are usually unplanned. There are around 700K blades in operation, and there are about 3,800 incidents of blade failure annually. And then offshore turbines, the failure can occur faster because of the corrosive sea environment.
And then some common areas of failure and fracture in the turbines is usually protruding parts, tapered, and transitional areas within it, and any bond lines due to resin and glue that exist on the turbines, whether that's the blade or just other parts of it. And since the blades are handmade, there's no like set production standard. So because of that, it's not really regulated, so it's easier for those to fail as well. And then within these links, we have various failure modes, and this is one of the graphs or images, diagrams that were in the articles. So we have a couple of failure modes here, the damage that occurs to trigger this failure mode, and then the performance status after this failure mode.
So one of the causes of wind turbine failure is a fracture of the main shaft. Some wind shafts experience shaft fractures at the variable section of the shaft. This is usually common during the early stages of operation. When we look at the finite element analysis, we see that there are stress concentrations at the main shaft, and these are usually worn down to fatigue. And then another potential influence could be that the hardness of impact property at low temperatures are sufficient. And there are two links here that talk more about that.
Some wind turbine failure prevention and improvement. As previously stated, a lot of the error in wind turbines comes from damage to the main shaft. And according to these links, some research has been done to see if there can be any improvement to the main shaft. And improvements to the main shaft of a wind turbine have been suggested through using finite element analysis. Some of these suggestions made came from the testing, and it involves moving the inner diameter of the main shaft forward in order to increase the structure's strength. And they recommended that some types of treatments and processes can be used in order to increase the fatigue strength of the main shaft. And one such process was a cold process. It was called rolling. Another website suggested inputting fault warning systems, and these are in place to detect any faulty equipment with the wind turbines early on. And this could lead to timely repairs or replacement of faulty parts. And thus, this results in the improvement of the reliability and stability of the wind turbines. And overall, these two different types of tests involving finite element analysis and fault warning systems were discussed in these two links below.